Urban and Public Affairs. Welcome to our symposium. We're going to start in 2-3 minutes. Meanwhile,
turn volume.
All right, I guess talk louder. Well, one more time. We're going to start in 1 or 2 minutes. Please pick up your report, Florida Resilient Coast, published by our Center for Urban and Environmental Solutions. Welcome to the College of Architecture, Urban and Public Affairs. Welcome to Florida Atlantic University. Welcome to our symposium. I'm going to wait 1 minute and we're going to start. I would like the science panel to come and sit here. The symposium is organized by the John DeGrove Eminent Scholar Chair in Growth Management and Development. My name is Ephraim Ben-Zedel. It's my pleasure to represent the DeGrove Chair this afternoon. This is our 3rd annual conference, our 3rd DeGrove conference, where we bring scholars and practitioners who work in the area of growth management, sustainable development, and smart growth. We would like to promote an exchange between academic and practitioners. We also would like to engage the public in a critical discussion. So, to do that, we have 2 panels today. The first panel is our science panel. The science panel is going to discuss short and mid-range impact of climate change on urban and ecological system in South Florida. The practice panel is going to discuss policy alternative to address climate changes on the national, regional, state, and local level. Another task of the practice panel is to respond to the scientists in terms of the impact of climate change on South Florida. Florida is our focus. Florida and South Florida is our focus today. We are vulnerable to climate change. We are vulnerable to sea level rise and hurricanes and other climate changes. And at the same time, we are also vulnerable socially and politically. We have 67 counties, 470 local governments, and 18 million people. We are well known to be one of the most divisive and fragmented states in the Union. In fact, we are rated in political science book now. We are promoted like from number 5 to number 1 recently. You can see the table. This is a 2007 textbook, and this is in terms of hyper-interest group activity. The state with the highest level of interest group activity formally now is Florida. I think there's maybe one more state next to us, but Nobody can compete with us in this area. So we are talking about a fragmented state, a short civic history because of many transients who came here since the 1950s, 1960s, and one of our important challenges is how do we get towards a more organized, towards more planned action to face climate changes. What is the role of the state in that? The role of the state can go from a centralized planning with mandatory measurements, all the way to decentralized with voluntary management, voluntary measures. And then between this mandatory and voluntary, perhaps another approach is just to have economic incentives to local government and regional institutions. So these are the kind of things that we would like to look at, especially here in the College of Architecture, Urban and Public Affairs, where very few of us are actually dealing with the science side, with the natural science sides of climate change, and that's why we got this panel together. Most of the panel, we have 2 guests here today from other universities also. So these are the kind of things that we would like to look at. Up to this point, if you look at the last decade or so, states were in the forefront of climate change policies. But perhaps with the new scene in Washington, this is going to change now, and the federal government will take a more significant role. No matter what, states are still at the forefront of climate change policies. So we are going to start with the science panel. I would like to introduce my colleague, the director of the School of Urban and Regional Planning at FAU, Dr. Jaap Roos. Thank you.
Thanks, Ephraim. Good afternoon, everybody. We started doing this conference, I think it was a year ago, and Ephraim, Murley, and I sat down and we decided that the most interesting thing to do with climate change was to start looking at how science can inform policy and how policymakers can inform scientists. So that's why we decided this time to have a conference where we have a science panel and a policy panel, and I hope that at the end we actually have time for some dialogue between the two. I think we have a really interesting science panel, and the composition of the panel I think shows you how interesting climate change is. I studied environmental science in the early 1980s, and we thought problems were very complicated. And the most complicated problem that we had at that time was really, in the Netherlands, it was mostly about solid waste management. And now I think back about those issues and I'm like, boy, that was easy. The problems that we're facing today are much more complicated. They're much larger scale, they require much more complicated solutions, they require much more input from different scientists. So today we have 3 scientists. We have Dr. Harold Wanless. He is going to talk about rising sea levels in South Florida. After him, we're going to have Dr. Margaret Cook, who's going to talk about climate change in marine ecosystems. And after that, we're going to have Dr. Diana Mitsova, who's going to talk about urban assets at risk. She's going to really talk about the urban environment. My job is just to introduce them and to keep them on track, to make sure that you get out of here at a decent amount of time. So our first speaker is going to be Dr. Harold Wanless. He's a professor and chair of the Department of Geological Sciences at the University of Miami. He has a PhD from Johns Hopkins University, a Master of Science from the University of Miami, and a BA from Princeton. He and his students have been studying the dynamics and evolution of tropical, shallow marine and coastal environments of South Florida and the Bahamas since the mid-1960s. Especially important to this research has been documenting the influence of changing sea level and catastrophic events such as hurricanes. They're now using this understanding to better predict the future of our coastal environments in the face of global warming. Dr. Wanless is also actively interacting with policy and legislative group to guide necessary decisions. He is the chair of the science committee of the Miami-Dade County Climate Change Advisory Task Force, and I think last year he spoke at the Everglades Coalition and gave a keynote address there. With that, Dr. Wallace.
It's very nice to be here today. For those of you that are students, what I'm going to present to you is the fact that the previous generations have so screwed up the world that you have unlimited opportunities, whether you are in the sciences, medicine, law, business. And so don't go out here discouraged, because I really wish I was 20 again. I'd be right up studying ice along with John Van Leer, right, John?
Yeah, right.
It's where the action is. So, we're not only vulnerable, we're very vulnerable in South Florida. In fact, the Miami-Dade Broward area is probably the most vulnerable city area in the world. So I look at Shanghai and Mumbai and think they probably are right with us. We have nowhere to escape to. And you know how high we are here, you know. So you may think sea level's always sort of been where it is, and that's why you invested in something for your grandkids out on one of the beaches. Well, it hasn't been. If we could go back 120,000 years ago, we were in a previous interglacial. CO2 levels were a little higher, temperature was a little warmer, and sea level was about 20 feet higher. And that was Florida on the left. That would have been where your condos were. Following that, we moved into another ice age, and it got progressively colder, colder, and colder. Very chaotic, sea level going up and down, temperatures going up and down. But about 18,000 years ago, we were at the coldest part of this recent ice age. And sea level, because of water evaporated from the ocean, fallen on land and stayed as giant ice sheets, sea level was about 420 feet lower than today. Lower during the ice age. And that was Florida. You would have had to gone from Naples and driven another 100 miles to get to the edge, to the ocean. If you were out on the Florida Reach, you would have had to, where it is today, you would have had to go down the slope about 5 miles toward the Bahamas to get to the ocean. And you would have seen the cliffs of, you dive the wall in the Bahamas. That was like a mesa. The Bahamas were like mesas rising out of the water. The interesting thing is how we got from 18,000 years ago to today. And the curve from about 18,000 years ago on the left to today, we rose from 120 meters, a little over 400 feet below present sea level. We started and it rose quite rapidly, and then it slowed down over the last 7,000 to 8,000 years. But the way it really rose was like this. Pause and rapid rise as some other ice sheet would come apart, a little bit more warming or something, and that's how it came apart. Now, that's very important to understand. And let me just quickly apply that to South Florida. 4,500 years ago, Florida Bay in South End Florida looked like this. It was out of water. Might have been marshy and swampy. Dan Kimball probably would have been administrating it as part of the Everglades. And then between 4,500 years ago and 3,000 years ago, basically Florida Bay became invaded. Down in the corner is a little diagram of the last 5,000 years of sea level rise. And what you can see here is we're now understanding that sea level just didn't rise like this, but it had these jumps. And then pauses, little setbacks, and then another quick rise. And it was these quick rises that inundated Florida Bay. You can see the 1, 2, 3, 4 sort of correlating here. And then we had a pause of sea level about 3,000 years ago. And we had a slight global cooling, and sea level responded. And as shown in the graph here, we're picking it up from 3,000 years ago to about 2,500 years ago. Sea level went down